Okay, this is your Chapter 9 review on inequalities. The first 6 questions are your vocabulary. It says, number 1, a mathematical statement comparing expressions that may not be equivalent is called an inequality. So inequality right here. Inequality is your first one. Number 2, inequalities can be represented blank on a number line or blank using symbols. The word is graphically on a number line or algebraically using symbols. On a number line, a blank blank indicates the boundary point is not a possible solution. That is an open circle or an open boundary. Question 4, for the inequality x is greater than 5, the value of 7 is a specific solution that can be used, because any number greater than 5, 7 is one of those numbers. Number 5, on a number line, the value that separates solutions from non-solutions is called the boundary point. And finally, on a number line, a closed circle indicates a boundary point is a possible solution. Moving along to the next set of questions. Question 7 says, an internet business is preparing a flyer to advertise a sale. Express each statement as an inequality. So savings we're going to represent with the variable s. So savings up to, but not including. So up to 40% is greater than, sorry, that's not right. Any savings less than 40% would be your answer. So you can have that, or any savings less than, if you want to get really creative, you can express 40% as a decimal. So any savings that is less than 40% would be savings that are potential for this particular sale. For B, free shipping on purchases of $500 or more. So we're going to put free shipping. We'll even use 2 variables. Free shipping for purchases of greater than $500 or more. So we have to have greater than or equal to $500. So free shipping for any price greater than or equal to $500. And C, over 80 major items on sale. So we'll put items, I. Are there 80 items for sale or more than 80 items? There are more than. So it has to be greater than 80. All items that are greater than 80, because there's over 80 of them are on sale. Question 8, road racers are use bicycles that are designed to go as fast as possible. Cycling organizations place restrictions on bicycle designed to ensure fairness and rider safety. Express each of these as an inequality. The minimum allowable road racing bicycle mass, so the mass has to be less than or equal to 6.8 kilograms. So the mass of the bicycle has to be less than or equal to, or no, minimum allowable. So you have to have the reverse. So the max, the mass has to be greater than or equal to 6.8 kilograms. Because the minimum one you have to have is 6.8. So it can't be less than that. So the minimum is 6.8. So we have a sample like that. I made a mistake. And for B, it can be no more than 185 centimeters in length. So we'll put the length has to be less than or equal to 185 centimeters. Question 9 says verbally and algebraic. Anyway, both algebraically and verbally number line. So this is an open boundary point in A, so it does not include, but it says we'll just use all values for x greater than, all values greater than, and it appears to be 13. So that one, because it's an open boundary point, it does not include the number 13, but any value greater than would be expressed on that red line. And B, all values less than or equal to, and this is 8.2, 8.4, 8.6, 8.8, and 9. So it's all values less than 8.6 would be used. Question number 10 says sketch a number line to represent. So R, all values greater than -4. So if I put -4 here on a number line, -3 would be there, -5 would be there. All values greater than -4 cannot include it, so it's there, and any value that goes this way on the number line would be a value that is greater than -4. For B, all values less than or equal to 7. So I'll put my number line, I'll put 7 here, I'll put 6 here, I'll put 8 here. All values less than or equal to, so because it's or equal to, I put a closed boundary point. And that would be all values less than or equal to 7. For C, Now for C, it's a little bit weird because we have our number first. So start at your variable and read it backwards. And if I read it that way and I say T is all values, then I read all values less than 9.5. Because the all values was not being eaten when I said it, so therefore it's less than. So all values less than 9.5. Put my number line here, I'll put 9.5 in the middle. I'll put 10 over here, I'll put 9 over here. And all values less than 9.5 would be an open boundary point, because it doesn't include it. And any value less than 9.5. And our last question, D, V will represent all values. So all values less than or equal to negative 5/4. So if I think about negative 5/4, what I'm really thinking about is negative 1.25, right? Because that's an improper fraction, but as a decimal, if I divide it, it'd be negative 1.25. We can make this negative 1.5. We can make this one over here negative 1 if you wanted to, or if you wanted to use fractions, because that's what it's written in. You could use, let's see if I get this here, negative 6/4 and negative 4/4 if you wanted to. All right, that's the same numbers. So all values less than or equal to, so all values including it, so a closed boundary point, and all values less than that on a negative number line would go this way because negatives get smaller the farther down the line you go. For question 11, it says for each inequality in number 10, state one value that's a solution and one value that's not a solution. Well, we'll just look at C and D because they're the only ones I have left. So one value that could be a solution. So in C, T could be 9. That could be 1. But T cannot equal 10. That would be a value it can't be. And in D, V could be, if we wanted it to be, negative 1.5, but V could not equal negative 1. Those are some solutions that you could possibly have, but those are just simple ones. For question 12, solve each inequality. So now in A, if I isolate for B, I'm going to add 7 to both sides to isolate, and D is going to be any value greater than negative 3. Now when you're solving, not only you have to solve it algebraically, but then you have to represent your answer on a number line. Negative 3 would go in the middle, negative 4 is over here, negative 2 was over there. Open boundary point, and any value greater than negative 3. Put my arrow that way. For question B, it says 2.7 is less than A minus 2.7. Or I want to read it, A minus 2.7 is greater than 2.7 is probably the better way to read it. So I'll keep it like that. 2.7. I'm going to add 2.7 to both sides. I'm going to get any value greater than 5.4. 5.4 goes here, 5.3 goes here, 5.5 goes here. And any value greater than 5.4, open boundary, and any value greater. Question C says a third of a number, or a third of the value B, has to be less than or equal to the number negative 11. So to isolate, I'm going to multiply both sides by 3. And get any value that is less than or equal to negative 33 would be an appropriate B value to work. That's my solution. I won't bother doing it. And finally, D, negative 1/5 of C is greater than 3.2. So there's 2 ways you can do it. What I would probably do is I'd say, okay, we have decimals and fractions. I'm not going to get into the whole working with fraction thing. I don't like that. I'm probably going to rewrite it. Instead of using negative 1/5 as a coefficient Zoe, I'm just going to use negative 0.2 because it's the same number. And it's much easier to isolate the variable. So all I have to do is divide both sides by that coefficient. And I would get C. And what do I have to do when I multiply or divide by a negative value? I have to flip my inequality sign. So I have to flip that because I multiplied or divided. And let's just do this mentally. If I think of money, if I have $3.20 and I have to divide them into piles of 20 cents. How many piles can I make? I have $3.20. Dividing it into piles of 20 cents. I can make 16 piles, I think. And the answer is negative 16. Just to double check, I take my calculator here. 3.2. Oh, hang on. Gotta go up here with it. Hang on. All right, so 3.2 divided by 0.2 with a negative 1 equals 60, negative 60. Verify the solution number 13 is correct. So we have a number line that has an answer. So I'm just going to isolate the variable. So all numbers greater than multiplied. So I'm going to divide both sides by negative 5. Because I divided, I have to flip my inequality sign. And I have any value that is less than or equal to 8. And this clearly says any value greater than or equal to 8. So the answer is this is not right. And the correct solution would be taking that and going the other direction. So that guy just forgot to flip his inequality sign. In B, I'm going to divide both sides by 4 and get x is less than negative 2.5, and any value less than negative 2.5 is being expressed there, so that is the correct number line to express the solution. Question 14, we get into our story problems. It says Tim earns $14.50 an hour working for his parents' business during the summer. His goal is to earn at least $600 per week. How many hours will Tim need to work to achieve his goal? So how many hours means that H is going to equal how many hours? And then invariably, it's always that easy. So I'm going to make up how much Tim earns as an algebraic expression. So $14.50 an hour means you take the number of hours and you multiply it by 14.50, or that's how much he earns. $14.50 per hour. So that algebraic expression. So the money he earns here has to be at least $600. This has to be greater than or equal to $600. So that's the hard part, setting up that inequality. I'm going to isolate the variable by dividing by his hourly wage to figure out how many hours he has to work. Any hours greater than or equal to 600 divided by 14.5, 600 divided by 14.5. Nope, that's not right. Divided by 14.5. He has to work at least 41.37. And since you can't work a part of an hour, therefore, he must work how many hours? 42 hours. Save up enough money. If he works 41, he doesn't have enough, and they're not going to pay him for 37% of an hour. Danielle is treating her friends to ice cream. Each scoop of ice cream costs $2.25. She wants to spend less than $30. How many scoops can she buy? How many scoops? So X is going to equal how many scoops? And at $2.25 each, 2.25 multiplied by the number of scoops will represent the cost. So the cost she wants to spend, she wants this cost to be less than $30. So therefore, this cost has to be less than. Can it be equal to? No. So the cost she spends on ice cream has to be less than $30. Isolate. And X will be less than 30 divided by 2.25. 30 divided by 2.25. She can buy 13 1/3 scoops. Can she buy 1/3 of a scoop? Probably not. So if she wants to spend less, therefore, she can buy up to 13 scoops. Oops. Well, my P is backwards, but you get the idea. Question 16 we're going to skip because it's dull. Question 17, dull. Question 18, solve each inequality and verify the solutions. So we're getting in our two-step algebraic equations. So in this one, we're just going to solve it algebraically. We're going to add 5 to both sides to isolate. 1/3 is less than 15. What's my next step, Zoe? multiply both sides by 3, and any value that is less than 45 would work to satisfy the solution. So if I put any number right here that is less than 45, that left-hand side will be less than the right-hand side. However, if I choose a value that is greater than 45, then the inequality will no longer work because the left-hand side will be greater than the right-hand side is what I don't want. 9x plus 30 is greater than 13x. So when we have variables on both sides, if there is only an expression with a variable, you don't want to get rid of that. You want to get rid of it on the side that has more than one term. So I'm going to subtract 9x from both sides. Algebraic zero pair. 30 is greater than 4x. Some people think you have to flip the sign because you subtracted 9x or put a negative 9x on that side, but it's only if you multiply or divide by a negative number do you flip the sign, so you don't flip it there. Divide both sides by 4, and any value less than 7.5 is a solution that is fine. In C, same idea, you have variables on both sides. So, sorry. Now, I'm going to make a mistake. No, I'm not. I'm going to make the right answer. So because you only have one term on this side and you have two terms on this side, subtracting 3x from both sides will work, but it just means you'll have a 0 term on there. It makes it a little bit more complicated, but not terrible. So what I'm going to do is I'm actually going to subtract 8x from both sides, leaving me with 5 on this side and negative 5x over here. Now once I do that, I'm going to divide both sides by negative 5 to isolate. And any value, I have to flip my inequality sign because I've divided by a negative number. Any value greater than or equal to negative 1 would work in the solution. Question number D, 5x plus 8 is less than 4x minus 12. If you have two terms on both sides, it's easiest to get rid of the variable term that is the least amount, so I'm going to subtract 4x from both sides. It usually keeps your coefficient positive. Not always, but usually. Once we get it down to that, we're going to subtract 8 from both sides to isolate for x. And x will be any value less than negative 20. Question E, 17 minus 3x is less than or equal to 7x plus 3. Again, we have two terms on both sides. I'm going to get rid of it on the side that has the least amount. So I'm going to add 3x to both sides. Getting rid of this term entirely. 17 is less than or equal to 10x plus 3. I'm going to subtract 3 from both sides. 10x is greater than or equal to 14, positive 14. Divide both sides by the coefficient, and it's 10, so I don't flip my sign. Any value greater than or equal to 1.4 will satisfy the inequality. And our last question in question 18 says distributive property. So the first thing I'm going to do is expand both sides using distributive property. Give me 6x plus 8 is greater than 30x plus 35. We have a binomial on both sides, so I'm going to get rid of the algebraic term that is the least amount by subtracting 6x from both sides. You don't have to, but you can. 8 is greater than 24x plus 35. Subtract 35 from both sides. 24x is less than negative, what is that, 25, 26, 27? That's weird. That's weird. Divide both sides. Oops, where'd that come from? Oh, like Garbo. Divide both sides by 24. Any value that is less than negative 1 and 3/24, or in lowest terms, negative 1 and 1/8. And your last question is your story problem with variables on both sides. Greg is considering two different plans. Which one, how many tracks purchased would make a better deal? So X is going to be equal to the number of tracks. And the expression for A, if it's 97 cents per track, then 0.97 multiplied by X will be the cost for that. Plus, he has this per month, and plus he has this per month. So as a constant, in addition to the number of tracks he purchases, he has to pay an extra $25 for fees. And then for plan B, it's 99 cents per track, so you're going to take 99 cents and multiply it by the number of tracks. And it's $9 a month. And the problem is it says $144 a year, but since there's 12 months in a year, 144 divided by 12 is $12. So 9 plus 12 means your constant is 21 bucks a month. $9 per month for the PC streaming plus $12 for the downloading. So it says, how many tracks would make plan A the better option? So this has to be the better option. So this cost, excuse me, there's 7 there. If that's the better option, it has to be less than this one, if it's the better one. Okay? So 0.97x plus 25 has to be less than plan B. We're going to subtract. Subtract this from both sides to get rid of the variable on one side. Having 25 is less than 0.02x plus 21. I'm going to subtract 21 from both sides. And 4 must be less than 0.02x. Or if you want to read it backwards, this must be greater than this. Oh. Now that we have that, we're going to divide both sides by the coefficient. How many 2 cents are there in $4? There are 50 in $1, so there should be 200, I think. So X must be greater than 200, I think. Let's just do that. So I have $4 divided into piles of 2 cents. How many piles can I make? I can make 200. So therefore, any amount of downloads, any amount OUNT of downloads greater than 200 makes A a better choice.